Oh, hi friend, didn't see you there. Triangle proofs can be quite difficult, and most people don't like them. But today, in my two-part foolproof proof survival guide, I'm going to teach you every aspect of triangle proofs, and hopefully make you hate them a little bit less. In part 1 of our foolproof proof survival guide, we'll be discussing what proofs are, how to solve them, and give you some practice problems to try at home. Proofs are mathematical statements that use logical properties and theorems to prove that another mathematical statement is true. The first method to solving triangle proofs is side, side, side. If the three sides of one triangle are congruent to the three sides of another triangle, then the two triangles are congruent. In this proof, we are given that line AE is congruent to line BC, line AD is congruent to line BD, and D is the midpoint of line EC. We have to prove that triangle ADE is congruent to triangle BDC. First step to correctly solving this proof using side, side, side is to state our givens, as with every single proof. After we have done that, the second step is to prove that line DE is congruent to line DC, and we can do that because of definition of midpoints, which states that the two sides of a midpoint are congruent. Now that we have this, we know that all three sides of this triangle are congruent to all three sides of this triangle, which means we can prove that triangle ADE is congruent to triangle BDC using side, side, side. The second method of solving triangle proofs is side, angle, side. In side, angle, side, if you can prove that two sides in the adjoining angle of one triangle are congruent to the two sides in the adjoining angle of another triangle, those two triangles are congruent. In this proof, we are given that AC is congruent to DF, CB is congruent to FE, and CB is parallel to FE. The first step is to state our given, and the second step is to prove that angle ACB is congruent to line GFH using alternate exterior angles. We do this so we can prove that line DFE is congruent to line GFH due to vertical angles. And now we have the two adjoining angles of the two sides of that are already congruent. So we can prove that triangle ABC is congruent to triangle DEF using side, angle, side. The third method of solving triangle proofs is hypotenuse leg. In hypotenuse leg, if you can prove that a leg in the hypotenuse of one right triangle are congruent to those of another right triangle, those two right triangles are congruent. In this proof, we are given that line AC is congruent to line BD, and we have to prove that triangle ABD is congruent to triangle DCA. The first step to solving this proof correctly using hypotenuse leg is to state our given. Second step is to prove that line AD is congruent to line DA using the symmetric property of equality. Now we know the hypotenuse and the leg of one right triangle are congruent to those of another right triangle, so we can prove that triangle ABD is congruent to triangle DCA using hypotenuse leg. The fourth method of solving triangle proofs is angle, side, angle. In angle, side, angle, if you can prove that the two angles in adjoining side of one triangle are congruent to those of another, those triangles are proven congruent. In this proof, we are given that E is the midpoint of line CB and angle ACE is congruent to angle DBE. We have to prove that triangle AEC is congruent to triangle DEB. We can do this by first stating our given. After this, we prove that line CE is congruent to line EB using definition of midpoints. After that, we know that angle AEC is congruent to angle DEB because they are vertical angles, which automatically makes them congruent. Now that we know that two angles in the adjoining side of one triangle are congruent to those of another, we can prove that triangle AEC is congruent to triangle DEB using angle, side, angle. The fifth method of solving triangle proofs is angle, angle, side. In angle, angle, side, if you can prove that the two angles in a non-adjoining side are congruent to those of another triangle, you can prove that those two triangles are congruent. In this proof, we are given that line AB is parallel to line DC, as well as that angle ADC is congruent to angle CVA. We have to prove that triangle ABC is congruent to triangle CDA. First, we state our given. Second, we prove that angle DAC is congruent to angle CBA using alternate interior angles. Like that. Third, we prove that line AC is congruent to line CA using the symmetric property of equality. Now that we have two angles and one non-adjoining side of one triangle being proven to be congruent of those of another triangle, we can prove that triangle ABC is congruent to triangle CDA using angle-angle side. Here are two methods of proof solving that do not prove that two triangles are congruent. The first one is a side-side angle. It does not work because, as we can see here, these two triangles have two congruent sides and a non-adjoining angle, and all those three are congruent, but the two triangles are obviously not congruent. The second method of proving that two triangles are congruent is angle, angle, angle. It doesn't work because, as we can see, the three angles of this triangle are congruent, but the sides are not. Therefore, neither of these will work to solve a proof. Now that you know the 5 methods to solving proofs, try solving these proofs on your own using the specified method. Pause the video now. Here is a proof using hypotenuse leg for you to solve. Pause the video now. And here are 2 final proofs using angle side angle and angle angle side for you to solve. Pause the video now. Answer to the proofs in 3, 2, 1. Pause the video if you need more time with those two. Here is the hypotenuse leg. Pause the video if you need more time. And finally, angle side angle and angle angle side. Pause the video if you do need more time. That's all we have time for this week, folks. Be sure to join us next week for part 2 of my foolproof proof survival guide.